Okay, so what if everything we think we know about the universe, from the tiniest little particle to the biggest galaxy, what if it's all built on a shaky foundation? Today, we're going to dive into a pretty radical idea, one that tries to rewrite the basic rules of physics. It's called dynamic vacuum field theory, or DVFT for short. And it suggests that everything we see, everything that exists, actually emerges from a single underlying physical thing, the vacuum of space itself.
So to even understand why someone would try to do something so ambitious, we have to start with what we're going to call physics' great divide. And this quote, it really nails it. Our two best theories about how the universe works, general relativity and quantum field theory, well, they're brilliant, but they absolutely do not work together. It's like having two geniuses in a room who just speak completely different languages.
And this slide, it just lays that divide out perfectly. On one hand, you've got general relativity. That's Einstein's masterpiece, right? It describes the big stuff, planets, stars, entire galaxies. In that world, gravity isn't really a force. It's just the shape of space-time bending and warping. But then, on the other hand, you have quantum field theory. It runs the bizarre tiny world of subatomic particles. And down there, forces are all about particles being exchanged back and forth. One is smooth, geometric, predictable. The other is chaotic, jumpy, and all about probabilities. They just don't mesh.
Now, this conflict isn't just some problem for academics to argue about. It's the very reason we're completely stuck on some of the biggest questions in all of science. Dark matter, dark energy, what on earth is going on inside a black hole, or what happened at the Big Bang? All of these mysteries are really just symptoms of this deep division in our understanding. They're the cracks in the foundation where our best theories just fall apart.
So how does this new theory even propose to fix all this? Well, here's our roadmap for today. We're going to start with the core idea, which they call the living vacuum. Then we'll see how that simple idea claims to get rid of dark matter entirely. After that, we'll explore its biggest ambition, to be a theory of everything. And we'll wrap it all up with a pretty important final question.
All right, let's get right into the heart of this thing. DVFT starts by changing the main character in our cosmic story. It says the vacuum of space isn't just an empty stage where things like matter and energy do their thing. No, it says the vacuum is the main actor. It's a real, dynamic, physical substance that's underneath everything.
And this equation right here is the engine of the whole theory. Now don't worry about the math, just focus on the two big ideas. First, you've got that rho symbol, rho. That's the amplitude. Just think of it like the vacuum's density, or maybe its stiffness. Then you've got theta, theta. That's the phase. You can think of this like the vacuum's internal rhythm, its own little clock that's constantly ticking and changing everywhere.
To make this a little more concrete, try to imagine the entire universe is filled with this huge, invisible, and incredibly stiff gel, almost like a superfluid. In this picture, matter, like you and me and the stars, isn't a separate thing. It's just a localized disturbance, maybe a little knot or a compressed spot inside that gel. And the forces we feel, those are just vibrations traveling through this stuff.
Okay, so cool idea, but does this new picture actually solve anything? Well, the theory's first huge claim is that it can tackle one of the biggest mysteries in cosmology, dark matter.
The problem itself is actually pretty simple to state, but it's a real head-scratcher. When we look out at galaxies, the stars way out on the edges are spinning way too fast. Based on the gravity from all the stuff we can actually see, the stars, the gas, the dust, those outer stars should just get flung off into deep space. But they don't.
And when you look at the numbers, the difference is just staggering. The speed we predict based on visible matter is way, way lower than what we actually see. So the standard solution for decades has been to basically invent a new, invisible substance called dark matter to provide the extra gravity. It works on paper, but the problem is we've never ever found a single particle of it.
DVFT comes at this from a totally different angle. No new particles needed. It says that way out on the edges of galaxies, where gravity is really weak, the vacuum itself just behaves differently. It enters a state the theory calls a deep field regime. And in that state, the vacuum's own stiffness creates an extra gravitational pull all by itself, adding to the pull from the matter we can see. And here is where the rubber really meets the road. This is the theory's first big, testable claim. According to the source material, if you just take the mass of the visible stuff, what scientists call baryonic mass, and you run it through the DVFT equations, the results are pretty amazing. For a galaxy like our neighbor Andromeda, it predicts a rotation speed around 220 kilometers per second, which is almost a perfect match for what we observe. It claims to solve the whole mystery with nothing but the vacuum.
But getting rid of dark matter, that's really just the beginning. The true ambition here is way bigger. It's to build a single, unified framework for all of physics, one that could potentially solve all of those cosmic mysteries we talked about. So remember that problem of infinite density inside a black hole, the singularity? Well, DVFT claims the vacuum's own stiffness acts like a cosmic safety net. It literally won't let matter be crushed down to an infinitely small point. Instead of a singularity, the theory says you get a vacuum core with a finite density at the center. No more infinities. The Big Bang gets a similar makeover. The theory suggests the beginning of our universe wasn't some explosion from an infinitely dense point. It was more like a phase transition. Think about water suddenly freezing into ice. It was the moment the vacuum field settled down from a much more chaotic, high-energy state into the reality we have today.
It also has a really interesting take on the famous Higgs boson. You know, in the standard model, the Higgs is this whole separate field that gives other particles their mass. But in DVFT, the Higgs is just a natural vibration of the vacuum's own amplitude. That rho we talked about, it's just a ripple in the fabric of the vacuum itself, not some add-on. And all of this leads to the theory's holy grail, its ultimate claim, the unification of the four fundamental forces of nature. DVFT says that gravity, electromagnetism, and the two nuclear forces, the strong and the weak, aren't separate things at all. They're just different ways that this one single vacuum field can behave.
So how does that even work? It's surprisingly elegant. The theory says gravity is just what we feel when the vacuum's density, rho, changes from one place to another. Electromagnetism? That's what happens when its internal rhythm, theta, changes. And the two powerful nuclear forces? They're just more complex wiggles and ripples in that same rhythm. It all boils down to one powerful idea. Four forces, one single field. So if we just take a step back and look at the whole thing, DVFT isn't just suggesting a few small corrections to our current theories. It's asking us to completely change our picture of what reality is actually made of. And I think this quote from the source material just says it all. In this new picture, all the big ideas in physics are just emergent properties of the vacuum's behavior. Gravity, quantum mechanics, even mass itself. They aren't fundamental things. They're just different things the vacuum does. Now, let's be clear. This is just one proposed theory. It has a very, very long way to go before it's accepted by the wider scientific community. But its incredible ambition, its attempt to unify everything from the ground up, forces us to ask a really profound final question. What does it actually take for a single new idea to come along and reshape our entire picture of the universe?